systems of equations with geometry. Okay, so we're working with some word problems here. All right, we're not automatically given all of our equations. We're going to have to pull some out ourselves, pull some out of the words. Okay, we are going to spend 2 days on this worksheet, on this packet, so I will make sure that you are clear before we leave how many of these you have to do for homework. Does that everybody understand that? Yes? Okay, so let's start with number 1. A rectangular enclosure has an area of 384 square feet, but its perimeter is only 80 feet. So fact number 1, list possible lengths x and y for rectangles with an area of 384. How are we going to get the y values if we know the x values? We're talking about areas, so we have to take the area and divide by the length of the rectangle, correct? Won't that give us the width? Good. So what if x is 10? What is y? 38.4? Everybody agree? Okay. 38.4. What if x is 12? 32. Okay, somebody else? What if x is 14? What's 384 divided by 14? Everybody's going to have to do at least one of these, so go and get your calculator out and ready to go. So how about if we say 27.43? Would that work? Okay. What about 16? If x is 16, what is y? Somebody else. 24. Good. What about if x is 18? So 21.33. Okay. We're going to go ahead and round it to just 33. We're going to round it to the, what place is that called? Hundredths, right? Tenths is the first one, hundredths is the second one. Let's round to hundredths in this problem. What about if x is 20, what is y? 19.2, okay? There's 2 more down here. What do you think we should put in there? So if we go by the pattern, does it go 2's all the way down? So let's break pattern. Let's go 30 and 40. Anybody have a problem with that? If you do, get over it. So what if x is 30? What's y? 12.8, good. And what if x is 40? 9.6, okay? Now, some of you already know this answer. I know because I heard you say it earlier. I wasn't just ignoring you. We're just not there yet. In this case, what equation would relate x and y? How did we get the y's? Very good. 384 divided by x. Okay? So let's look at fact number 2. List possible lengths and widths for rectangles with a perimeter of 80. Thank you. If we know the length is 10, how do we find the width if we're talking about perimeter? Some subtraction is going to have to go on, right? 80 minus 20, but this says 10, Emilio. Oh, we have to double it because we're talking about perimeter. That's perfect. So we have to take 80 and subtract 20, and then divide by 2. Why? Because there's 2 sides, okay? So what is 80 minus 10? Divided by 2? 30. Very good. So what if x is 12? 80 minus 24 divided by 2. 28. What about this one? 14. Ask me. 80 minus 20 is 60. 60 divided by 2 is 30. Okay? No, that's fine. Good question. We're down here at 14. Who hasn't given me an answer yet? Has everybody answered one? Okay, then we can start over again. What is 80 minus 28? Divided by 2? 26. No, that's fine. What about 16? Can you tell me the answer is 24 without doing any arithmetic? Can you tell me what the next answer is? How do you know that? It's a pattern. Okay? So what about here? 20. So what if I said 25 and 30 this time? Can we still go by the pattern? What's 80 minus 50? 30 and half of 30? 15. What about 30? 10. How did we get y? What equation would relate x and y? $80 minus 2x all over 2? Okay. Oh, that's a good question. Could we say y equals 40 minus x? We could. Okay. What is this? Like, where did that come from? What formula did this actually begin with? 2x plus 2y equals 80. And what's that? That's perimeter, isn't it? Okay. 2x's plus 2y's equals the perimeter. So algebraically, we just subtracted 2x from both sides and divide everything by 2. You okay with that? So we could have y equals 40 minus x. But this one looks a little bit closer to perimeter than this one, doesn't it? So you can have this one if you want. I want you to especially have this one so you know actually where it came from. Fair enough? Okay. So go to the middle now. What ordered pair appears to solve the system? I'm not touching my calculator, are you? So which ordered pair appears to solve the system? What's true about a point that solves the system? Where would it appear? On both tables. Absolutely. What point appears on both tables? Here and here. They were even nice and put it in the middle. Okay? 16 and 24. Is there another possibility? So the only possibility is for x to be 16 and y to be 24. So you're arguing with me. Not arguing with me, just saying there's not another possibility, right? So what if I wanted to argue with you and tell you there is another possibility? You would what? You'd say prove it. Okay, can I prove it to you? Okay. What if x was 24 and y was 16? Isn't that a different rectangle? It's shaped differently. Okay. So is that kind of tricky to begin with? A little bit, okay? But the other possibility is 24, 16. So graph the system or solve it algebraically to confirm. So whenever they do this to me, my very first question is, where the heck am I supposed to do that? Clearly I could graph the system in my calculator, but there's no work to show, is there? So let's write Sierra-like for a moment. 384. I'm sorry, Sierra. You're writing injustice. That's really big. Okay, I apologize. Equals 40 minus x over 1. Say again? She has little eyes. She's exactly the size that God made her. She's exactly the size that God made her, which makes her perfect. Okay. So here we have 384 equals x times 40 minus x. Okay so far? Does this look familiar? Good, we did it last week. Oh yeah. That was when Jordan was in San Antonio. $384 equals 40x minus x squared. What do I like my x squared to be? Positive. So I want to add x squared to both sides. And I want to subtract 40 from both sides, 40x. Okay, now it becomes a problem. So I'm going to go over here. I have x squared minus 40x plus 384 equals 0. So I have two possibilities, two possible choices. More than that, but two that we kind of are familiar with. Factoring or quadratic formula. Okay, so you want to factor? Okay, so I have to figure out multiples of 384 that give me a sum of negative 40. Is that possible? If they're both negative, right? Okay. 1 and 384, 2 and 192. Is it divisible by 3? Yes. Wait, how do I know it's divisible by 3? Just by looking at the number. Do you remember? What's 3 plus 8? What's 11 plus 4? I added up the digits and got 15. Is 15 divisible by 3? Then that number is divisible by 3. That works with 3's, and it always works with 3's. Okay? 128. What about 4? I'm pretty sure it is divisible by 4. 96, so I'm not there yet, right? It's not divisible by 5, is it? How do you know? Doesn't end in 0 or 5. Good. What about 6? Could I tell you that I knew by looking that it was divisible by 6? I mean, I don't want you to think I'm making it up, but if a number is divisible by 2 and 3, then that number is also divisible by 6. Okay, what is it? 64, so I'm getting closer. What about 7? 8 is? 8 and 48, so I'm getting closer because I need negative 40. Ooh. No, they both have to be negative or both have to be positive, right? Because the sign at the end is a positive. So that's a good point. I could subtract this from that and get 40, but that wouldn't work as far as my signs go. So 10, no. 11, no. 12, 12 and 32. So that's getting closer because that's 44. So it's still not working. 13, 14, 15, 16 and 24. Oh my gosh. It would have to be x minus 16 and x minus 24, right? Oh my gosh, look at the answer that we got. How exciting. Because remember we set these equal to 0 and we get x equals 16 and x equals 24. Guys, this tells us more than I think you realize. Did it give me the point 1624? What does it say? X equal. X equal. It's telling me that x can either be 16 or 24. Doesn't it give me both of these 2 points? So this is, remember a second ago when you said prove it? I showed it to you like on the graph, but now I've proved it algebraically to you that it could be 2 possibilities. Fair enough? Okay, look at number 2. Are we good on that one, by the way? Any questions about it? Okay, number 2. In a right triangle, the hypotenuse measures 6.5 centimeters and one leg is 3.5 centimeters longer than the other. List possible lengths x and y for the legs of a right triangle with a hypotenuse of 6.5 centimeters. Well, what are we even talking about here? Pythagorean theorem. So can I go ahead and fill that in first? X squared plus y squared equals what again? So 6.5 squared? Do you know what 6.5 squared is off the top of your head? I don't. But we could figure that out, right? We probably need to. 42.25. Okay? So I have to take x squared. Sorry, I have to take x and square it. How am I going to solve for y? I'm going to have to end up finding the square root, right? Okay, so it's going to be 1.82 squared plus y squared equals 42.25. So if I subtract x squared's value from 42.25, that'll give me y squared, won't it? Okay, so what is 42.25 minus 1.82 squared? I'll say it again. 42.25 minus 1.82 squared. Okay, so what is the square root of 38 point... Exactly? Nice, 6.24 exactly. So wait, what you told me was that we take this number and subtract the x squared value from it? And then to find y, I would have to take the square root of that, right? Okay. So is that a little faster to get your value? Okay, so what is the square root of 42.25 minus 2.5 squared? 6. Excellent. What about 42.25 minus 3.9 squared? 5.2. Excellent. Okay. So what about fact number 2? If x equals the length of the shorter leg, list possible measures for the sides that are 3.5 centimeters longer. If x is 1.82, what's 3.5 centimeters longer than that? Uh-huh, 5.32. If x is 2.5, what is 3.5 centimeters longer than that? 6. If x is 3.9, what is 3.5 centimeters longer than that? 7.4. What ordered pair appears to solve the system? 2.5 and 6. It appears in both tables, right? So 2.5 and 6. Is there another possibility? So how do you think we should fix to confirm it? Same way? Okay. So, which equation relates x and y in this problem? So y equals x plus 3.5, right? So to solve this system, I'm going to turn my paper again after I start it. I would have to say x squared. I would have to do substitution on this one, right? Put this in for y right there. So x squared plus x plus 3.5 squared equals 42.25. So this is really x squared plus x plus 3.5 times x plus 3.5 equals 42.25. x squared plus x squared plus 3.5x plus 3.5x plus, what's 3.5 squared? .25 equals 42.25. Okay. Now I'm turning my paper. You have this already? Sorry, I'll wait. So I have x squared and x squared, so that gives me 2x squared. And I have 3.5x and 3.5x, so 7x plus 12.25 equals 42.25. How do I solve that? Excellent, set it equal to 0. What is 12.25 minus 42.25? Minus 30? So I either can factor this or I can solve it by quadratic formula. You want to try to factor it? Okay, if I try to factor it, I get AC is 60, right? So what multiplies to be 60? 1 and 60, 2 and 30, 3 and 20, 4 doesn't go, 5 and 12, ooh, 5 and 12, right? So this is one I can't just go straight to the factors, I got to split my middle term. 2x squared, and it's going to be minus 5x plus 12x minus 30. Can you even read my writing? Okay. So I'm going to go up over here now. 2x squared, oh sorry, 2, they're both divisible by an x, so I want to factor out an x. I have 2x minus 5 left. Both of these are divisible by a 6, plus 6, so 2x minus 5 left, that's good, right? So I end up with x plus 6 and 2x minus 5. So x equals negative 6 and x equals 2.5. Now, the good news here is that look what I got for this x value. 2.5, right? Okay. The other possibility is this. If x is negative 6. Negative 6 plus 3.5 is negative 2.5. That's my other possibility, isn't it? But what? Somebody draw me a triangle that has a length of negative 6 and a height of, or a y value of negative 2.5. Can't, right? We can't have negative distance, can we? Not in a situation like this. Okay? So, negative distance. Why can't I just flip this around like I flipped the last one around? 6 and 2.5. It is a triangle, not a rectangle, but don't we find area by length times width times height? No, that's volume, guys. 1/2 base times height, right? But it very specifically says x is the length of the shorter leg and the longer leg is 3.5 centimeters longer than the other. Y is 3.5 centimeters longer than the other. So could this one be 6 and this one be 2.5? Okay. Questions? We good? Okay. Please circle number 3. circle number 4 and circle number 5. Those are the 3 problems that you have for homework. Just those 3. Okay? Tomorrow when you get here, I have to take that back. I need you to do 6 also. Okay? 3, 4, 5, and 6. When you get here tomorrow, we're going to work on 7, 8, 9, 10, 11, and 12. Actually, let's see if we can make this easier for ourselves a little bit. Beside number 7, could you please write EC? Beside number 7, please write EC. What does that stand for? Extra credit. Okay? I'm not gonna have that one assigned to you at night because look how similar it is to. It is a little bit different, but look how similar it is to number 5. Isn't that very similar to number 5? Okay, no need to have you do a whole bunch of problems just because they're on the page. You know how I feel about that. Okay, so you are doing for homework which numbers? 3, 4, 5, and 6, and 7's extra credit. All right, any questions on this? All right, come and ask me if you have them. We'll work through them. Kingston out.